Welcome back. In this video we shall see how to obtain the maximum value in an array or a matrix. So let's define an array A. Its elements are 2, 5, 9, 0, 5, 3, 1. So the maximum value of A will be, we will use the max function, max A. So the maximum value in this array is 9. So max A is equal to 9. So next we find the location of the maximum value. So max A will be the first parameter and location will be the second parameter. LOC will be the second parameter of the function which it will return. So max A and LOC are output parameters of the function max. So is equal to max A. So maximum number is 9 and its location is 3. So this is first location, this is second location, this is third location. So maximum number is 9 whose location is 3. So what about two-dimensional arrays or matrices? So we define a two-dimensional array B. So let us find the maximum value of B. So max B is equal to max function B. So it will return a row vector. What it will return? It will return a row vector. For each column it will check in which row the maximum value lies. So for the first column it will see the maximum value in first column is 7. The maximum value in second column is 4 and the maximum value in third column is 9. So this is okay, but how do we find the maximum value of the entire matrix B? So we write max B is equal to max B. So max function will be called two times. First it will return the row vector which contains the maximum value from each column. Next it will find the maximum value of that row vector. So it will return 9. So in 2D case or in case of two-dimensional matrices or arrays, we have to use max function 2 times. So let us find the location of the two-dimensional matrix. So we will write max B location LOC is equal to max of B. So max of B will return a row vector and location will also be a row vector. So in this column, in first column, the maximum value is 7 which lies at the second row, which lies in the second row. In this column the maximum value is 4 which lies in the first row. So the 4 lies in first row. In this column the maximum value is 9 which lies in the second row. So it will max of B will find the maximum value in each column and will calculate the row number in which the maximum value lies. So how do we find? So let us use again this and add an input argument 2. So the default argument, or this is the dimension, this 2 is the dimension along which the max function will operate. So its default value is 1, so it will operate along the rows. So if we use 2 and we see the B matrix, so now it will operate along columns. So it will find the column number in which the maximum value lies. So we check for all the rows. For first row, the maximum value is 8, which lies in the third column. For second row, the maximum value is 9, which lies in the third column. For first row, the maximum value is 8, which lies in the third column. For second row, the maximum value is 9, which lies in the third column. For third row, the maximum value is 7, which lies in the first row. The maximum value is 7, which lies in the first column. I repeat, for this row the maximum value is 8, which lies in the third column. For this row the maximum value is 9, which lies in the third column. For this row the maximum value is 7, which lies in the first column. So if we place 2 here and use square brackets here, the max function will operate along the columns. So let us use 1 here. 1 is the default value and it will operate along the rows. So this is the output we already have seen previously. So what is there? But there is a problem about location. In this case, when we operated along the columns, it gave only the column numbers. In this case, it only returned the row number. But what we want is both the row number and the column number. For that, what we will do, we will write max b location is equal to max the max of b comma square brackets comma 1. So first it will operate along the first dimension, then we use another max which will operate along the second dimension. In this way we shall get so here we should also use square brackets. So first of all, this will calculate the maximum value in each column and will return a row vector. Second, max will calculate the maximum value along in the maximum value in that row vector, which is 9. So it will return the 9, and location is 3, which is, so we see the B matrix again. The location is 3, which is the column number. It returned the column number. So to get the row number, we first operate on columns and then operate on rows. First we will operate along columns. So what it will return? It will return a column vector. Then we will apply the max function along the rows. Then it finally will give the what it will give? It will give the it will give the row number. It will give row number. So it will give 2. So we obtained 3 here and 2 here. So the location of the maximum value in the matrix is 2 cross 3, because this 2 is the row number and this 3 is the column number. So the location is 2 cross 3, which means second row and third column. The maximum value lies in second row and third column, which is 9. So this is second row and this one is third column. So the maximum value lies in second row and third column. Here we obtained the row number, and using this method, by first operating on rows and then operating on columns, we get the column number. By first operating on columns and then operating the max function on rows, we get the row number. So we obtained the location of a 2D matrix in this way. So that's all for today. See you in the next video.